Hey guys, Dan from Xservice here. I'm just going to put together a quick video of us doing some domain enumeration against the Windows Server 2016 environment, and to see what we can see and see how enumeration of services can lead to progressing an attack. So we're just going to quickly log into Kali here. I'm going to throw up a terminal window. Now for this, I know the IP address that we're going to scan. We're going to run a quick scan against our target. I'm just going to do a standard port scan on the top 1000 ports. Nothing special. We can see here immediately that we've got a range of ports open. Now, I'm going to do a version scan against these ports as well. We're also going to specify the full port range. More on that later while it's running off. So we can see here that we've likely got a domain controller, we've got DNS, TCP open, we've got Kerberos, we've got LDAP, we've got LDAP Secure, we've got global catalog services. You know, this is highly likely domain controller. We're going to run NSLookup to do some manual DNS testing. We're going to specify our server. We're going to immediately send a reverse lookup on the server to see what it is. See, there's a zone. We can see here that we've got a reverse lookup for dc1.xlab.local on that IP address. We now know the domain name. We're going to type xlab.local, and we're going to see that there's only one address listed. So this is highly likely one domain controller in a forest. Now, there's a few different ways we could have got to this point. If we had dropped into the network on a target, we could have looked at DHCP information. You're often going to be assigned the domain name via DHCP. You could look at your DNS servers that you're assigned. If you're on a client machine, you've obviously got more enumeration activities there. But from an unauthenticated, just being dropped on a network point of view, we now know the name of the domain, and we know there's likely one domain controller with a range of ports open. Now that version scan is still running, so we're going to continue with some DNS enumeration. Now we can do quite a few bit of manual testing, we could do some brute forcing, but for this demo I'm just going to use DNS recon. If I could spell, we're going to specify the domain of xlab.local. We're going to specify the name server of 192.168.2.29, and we're going to see what we can see. So there we go, we have 11 records. That is like the most basic view you'll get, and if you just install a single domain controller, that's the view you're going to see when running DNS recon. We are, however, going to attempt some additional tests. We're going to attempt a zone transfer to see if we can dump the whole DNS database. Now, out of the box, this doesn't work against the domain. The zone transfers are disabled. So what we've found here is that there's a security misconfiguration or a weak configuration, and that luckily here zone transfers were successful. This leads us to see that there is a record for a server called secretweb.xlab.local, and that's on 192.168.2.8. While our full port scan's going on the domain controller, we're going to clear out the DNS records, and we're going to take a quick look at secret web. Now, I'm just going to send a curl command, if I could look at my keyboard and type, to this to see if there's a response. It's called secret web, so I imagine there will be something on port 80 or 443. So 80 has responded with HTTP responses. Just going to try HTTPS, and that's going to time out because it's not running. We're going to run a quick nmap scan. While that's just running now, we can just go back and see that the service version scan has completed, and we've managed to identify the domain name is xlab, xlab.local, and all the services that we previously saw still exist. One thing to note, we've got two additional services that are interesting. We've got terminal services, which is running on port 3389, and we've got Windows remote management likely on 5985. So we're going to keep them in mind for later. We're then going to go back to our web server. We know it's running open on port 80. We're going to just kick off a Nikto scan on that box. And we're going to have a quick manual look. And here we have super secret intranet. On this site, we're going to be looking for options for enumeration. We're going to try and find some intelligence and sensitive information. And we may find additional services we can abuse, such as logins, file uploads. We could do force browsing, etc. I'm not going to focus on web apps in this video. So what we're going to do is have a quick browse. We can see if there's any sensitive information. We've immediately seen xlab.local. Down here we can see a name of a human, Adam Jensen. And we can see an email address of intranet@xlab.local. Now, we're going to just minimize this. I'm going to get our port scans out of the way. We're going to look at scraping this site to see if we can get any information. Now, I'm going to target email addresses because we've seen that. We're going to use the tool kill to get this, and we're going to put the target in. We're going to generate a list of words from the page. More importantly, however, we've located Adam Jensen at xlab.local. So we've got a potential human target that we can attack. There was obviously the intranet at xlab.local. I tend not to attack shared services first. I tend to go for humans. They're more likely to have A, user accounts and not shared mailboxes, and B, we're more likely to be able to get some intel on them or guess a password or search have I been pwned for a previous breach, look at a GitHub, etc. There's lots of ways that we can get more intelligence around a human and potentially employ social engineering to attack that vector. But looking back at our Nikto scan on our website, it appears that we found some more sensitive information or potentially sensitive information. I mean, the first thing that slams out there is passwords.txt, readme.txt, and license.txt. So we've got 3 text files on our web server that really might be worth having an investigation into. You can do this in a browser, or you can curl it, or wget, whatever tools you like using. So we're going to grab that passwords.txt, and here we can see a message to Adam saying that the password has been set to winter 2019 ! Which has all the hallmarks of a weak password. Capital letter, common dictionary word, a year for complexity reasons, and then to really hit that extra complexity policy mark, we've got the trailing exclamation mark. So we now possibly have got the Adam's username and Adam's password. Now, what we're going to want to do is test that. Now, we know that web server is running port 80. We know the domain controller is running remote desktop, and we know it's running Windows remote management. Now, we could attempt to log into the domain to start with, or we could attempt to log into the web server. We've got some choices here. I'm going to attempt some actions on the web server target. So what we're going to do here is do a port scan on the web server, but specifically we're going to be looking for 5985. So and we're going to be looking for that 192.168.2.8. I'm going to throw in some version detection. And we can see the host responded to ping, and the TCP port 5985 has responded with an HTTP service. So this is looking like a likely candidate. Now, to attack this, there's a whole host of methods. We can use some Python, we can use Ruby modules, we can use MSF, we could use a Windows box. For this, I'm going to use MSF. I'm going to have a look for the WinRM modules. Just going to get this neatened up a little bit so you can see what's going on in MSF. And we're going to just do a quick WinRM login. So use auxiliary scanner WinRM login. Let's look at the options. Set domain xlab, set username Adam Jensen, set password winter 2019, set our hosts 192.168.2.8. Let's clear the screen. Let's check our options. So we've got 192.168.2.8, which is our target, running on port 5985. We're using Adam Jensen with our super secret winter-based password. We're going to run this module, and success. We can log into that box. Now, I'm going to leave MSF now. On server 2016 plus, at least, we can't use, to my knowledge, the MSF modules to log into WinRM from Linux. What we're going to do here is use a WinRM session using a Ruby method. I'm just going to tailor this to meet our environment. So we were targeting HTTP 192.168.2.8, 5985, Adam Jensen, winter 2019. Save that. And there we go. We can see that. If I can type. Just a note from a defender point of view, it's quite interesting to watch typos occur in your log files. You can then generally tell whether there's a human being behind your attack or whether it's an automated system. So we can see here that we are Adam Jensen on Secrets Web. And that we are running in a low privileged mode. However, we have Windows Remote Management access, so we can start exploring this machine. Right, so that's our demo over for today. I'm going to continue creating more content. Guys, if you can like, share, comment, give feedback. If you want to see anything particular demonstrated, please chuck a comment in and I'll see if I can get a video up. Thanks, guys. Bye.